In the last video, we understood about transpose of a matrix, correct? Now there are two special type of matrices, and they are symmetric matrix and skew symmetric matrix. Okay, now first let's understand what is a symmetric matrix. Okay, so now we are discussing about symmetric matrix. Now when we talk about symmetric matrix, what exactly is a symmetric matrix? We'll look into that. Okay, now see, in a symmetric matrix, what we have is the matrix and the transpose of the matrix, both are one and the same. Okay, that means a symmetric matrix is that matrix where A is equal to A transpose. Then we say that the matrix what you have is going to be a symmetric matrix. Now, first thing is, it's very obvious that a rectangular matrix cannot be symmetric. Think about it. A 2 cross 3 matrix, when you transpose, it will become 3 cross 2. So the elements will differ, correct? So that means it has to be a square matrix. Since it has to be a square matrix, now comes a very important point, that is the principal diagonal. Okay, so the principal diagonal, whatever we have, the elements above and below the diagonal will be the same. In the sense, see what we can say here is that, suppose say matrix A, first we'll start with 2 cross 2. Say this is 2, 5, and say this is 5 and 3. Now what I want you to understand is that, see here, the principal diagonal, this is the principal diagonal, correct? Now above the principal diagonal and below the principal diagonal, in the sense this element, they are one and the same, correct? So this is the key point in understanding what is a symmetric matrix. Alright, now when you talk about symmetric matrix, remember the elements above the principal diagonal and below the principal diagonal. And below the principal diagonal, both are one and the same. Okay, so above and below, we have the same elements. Same elements. That's when we say that it is a symmetric matrix. So first and foremost, a very important point is, all symmetric matrices are square matrices. Okay, so you can say that all symmetric matrices are square matrices. Because a rectangular matrix can never be symmetric, correct? Now let's take it for 3 cross 3 matrix. Okay, so for 3 cross 3, let's say we will take A is equal to, so 4, 3, 1, 3, 7, 8, 1, 8, 5. Now if you look at this, the upper triangle and the lower triangle, anyway, let's not go into too much of technical what it is. So what you know is, you know that this is the principal diagonal, correct? Above the principal diagonal and below the principal diagonal. So above the principal diagonal, see this 3, 1, 8, below the principal diagonal. So what we are looking at is that these two elements are same, these two elements are same, these two elements are same. Now this is what we mean by the symmetric matrix. Okay, now how do we define? The definition of a symmetric matrix is always with respect to this. A is equal to A transpose. Correct? The matrix and the transpose of a matrix should be the same. Then we call it as a symmetric matrix. And you guys understood all the properties. Now let's discuss about skew symmetric matrix. Okay, so the next type is skew symmetric matrix. Skew symmetric matrix. Now what we mean by skew symmetric matrix? Now here the matrix and the transpose of the matrix they are negative of each other. In the sense, suppose if I take B, then B is equal to minus B transpose. Now along with that, there is one more condition, that is the principal diagonal elements are 0. Okay, the first condition for a skew symmetric matrix is the matrix and the transpose of the matrix, they are negative of each other. That's the first condition. So the first condition I've written here, this one. The second condition is that the principal diagonal elements, are 0. Okay, now principal diagonal, generally principal diagonal also, you can tell both of them. So principal or principal diagonal. The principal diagonal for a skew symmetric matrix is 0. Fair enough? These are the two conditions. So here what we can write, that matrix B, first again we are going to start with the normal 2 cross 2 example. Okay, we will write 0, 5, minus 5, 0. See, if this is matrix B, transpose this, B transpose is going to become 0, minus 5, 5, 0. See, B and B transpose are negative of each other. That's why B is a skew symmetric matrix. Okay. Now let's do the next example, that is for a 3 cross 3 example. So for 3 cross 3, again let's talk about matrix B. So first one, it has to be 0, then say 3, 5, then minus 3, 0, minus 2, minus 2, 2, 0. See, this is going to be matrix B. Now, if you look at it, matrix B is actually skew symmetric in nature, because the principal element, all the principal element, that is the principal diagonal elements, they're all 0. Then look at the rest of the things. You have 3, minus 3, minus 5, 5, 2, minus 2. They're all negative of each other, correct? So when you do the transpose, B will be equal to minus B transpose. So this shows that how we can write one particular lesson. Suppose say you have a matrix, then is that symmetric or skew symmetric, correct? This is symmetric and skew symmetric. Now with using symmetric and skew symmetric matrices, we can express that a square matrix as sum of symmetric and skew symmetric matrices. Okay, now what exactly is that? We'll discuss that in the next video.